Good evening, dear students. Today we'll be discussing our second session on parabola in continuation of our first session, what we discussed in the previous class. And in the previous class, just a quick recap, we discussed about the different attributes of a parabola, like, what's the directrix. Then we discuss about, the vertex, the focus, the axis of the parabola, and the length of lattice rectum, and the standard equation of a parabola like y square equal to 4ax. Now, dear students, today what we are going to discuss, we are going to discuss about the parametric form. We start with the parametric form of a parabola. So now, before we start parametric form, so dear students, if you just have a visual representation of a parabola, and I show it in the adjoining diagram. Now, dear students, before I proceed further, could you please confirm that you are able to hear my voice very clearly and able to view the screen properly?
Yes.
Please confirm. Okay, great. Thanks for the confirmation. Okay, so if you see this equation, that equation, what I make 2 ended in arrow, that is the equation of the parabola y square equal to 4ax. And dear students, apart from y square equal to 4ax, what are the 4 other standard form? That is y square equal to minus 4ax, x square equal to 4ay, x square equal to minus 4ay, and y square equal to 4x, as I said. So there are total 4. But generally, dear students, that y square equal to 4ax is actually widely used. Whenever we see the a equation of a parabola, we say y square equal to 4ax. And the moment that y square equal to 4ax is actually is given to you, you can visualize, okay, this is the shape of that parabola. It looks like the parabola is something like this. Okay, it doesn't exactly matching with the black curve what is there. So this is what is actually called the y square equal to 4ax, dear students. Okay, so now what we are going to discuss about, we are going to discuss about the parametric form of this parabola y square equal to 4x. Now let us understand, in our previous classes also I discussed the significance of having a parametric form. If you see, but before understanding the significance of parametric form, we need to understand, when we say that y square equal to 4ax, there are two unknowns here, dear students. What are the two unknowns? One is x, one is y. 4a, that is a, 4a, that is the length of the lattice rectum, that is constant. So there are two unknowns. Now from these two unknowns, can you reduce it to one unknown? And parametric form is going to help us. So what its parametric form, dear students, is that x equal to 80 square and y is equal to 280. Okay, if you see that x equal to 80 square, y is equal to 280, here t is a parameter. So just with one parameter, you are able to express both x and y, two unknowns. And that is the significance of parametric form, dear students. In future, while solving, many more problems related to parabola, okay, and we will see that if we assume the parametric form, it actually, easier to solve the problem, especially in the problem related to calculus. So this is what is called the parametric form. I hope it is clear, dear students, that what is meant by parametric form. So, that so what is that t? T is a parameter, as I said. So now the point P will have a coordinate 80 square to 80. So that means if you take a point P on that parabola, okay, so for example, you take this parabola, in fact the diagram whatever I have seen shown here, if you consider this parabola, and that parabola is having a point P. In Cartesian coordinate system, its coordinate is alpha beta, but you can also write the coordinate of this point P as 80 square, comma 280. So instead of two unknowns, we are able to express, as I said few minutes back, that the point P is able to express with only one parameter. Okay, So any point PT, so now the point P is actually dependent on the parameter T. So that is why it is written as PT. So any point PT on the parabola y square equal to 4ax is given by 80 square comma 280, where T is a parameter and its value varies from point to point on the parabola. What is T? Now let us concentrate that what is that, what is the value T here? So the parametric form of the parabola y square equal to 4x, as I said, is that x equal to 80 square and y is equal to 280, with two information about the parameter T. Okay, and that I'm going to show you now here, dear students. That as you see, so the parametric form of parabola y square equal to 4ax is below, that x equal to 80 square and y equal to 280. Please note the 2 points. That first one is that in order to get the complete parabola, we need to vary t from minus infinite to infinite. So that means if you minus infinite to infinite means there are, it is an entire real number set. You take any value of t, you will get different points on the parabola. And you join all those points and you will get the exact shape of the parabola. So that is why it is written, in order to get the complete parabola. So we need to vary t from, in order to get the complete parabola, we need to vary t from minus infinite to plus infinite. Okay, now another information, the moment you take that 80 square and 280, a point, in that point, if you draw a tangent, the slope of the tangent is measured as 1 by t. This information, if you can remember, dear students, it is going to help you a lot in solving some problems related to tangent. That's what does it mean? It means is that, if I have a parabola, something like this, that parabola shape is something like this, that y square equal to 4x. Suppose you take a point P here. So this is the equation y square equal to 4ax. Now if you take a point here and if you draw a tangent at this point, now the slope of this tangent, so what I wanted to mean is that slope of the tangent is equal to 1 by t. So that information is very meaningful. So whenever you get a parametric point 80 square 280 on a parabola, its slope at that point P is 1 by t. Okay. So this is all about the parametric form of a parabola. Now, dear students, what I'm going to discuss with you is called the focal chord of a parabola. And that I'm going to discuss in the next page. So let us first understand what is meant by a focal chord. Chord you understood from the circle. Okay, what is meant by a chord? So here also you understood what is meant by a chord. Chord means is a straight line which will actually intersect the parabola and both the ends. If you see, that is what is called a chord. Now focal chord means is that, okay, it is a chord which passes through the focus of the parabola. Any chord to the parabola y square equal to 4ax which passes to the focus of the parabola is called a focal chord of the parabola. Now, why we are so interested about the focal chord? Okay, so let me show you by means of this diagram first, dear students. Okay, so let me first define what is meant by focal chord. So as you see, any chord to the parabola y square equal to 4ax which passes to the focus of the parabola is called a focal chord of the parabola. Now let us take that particular diagram. So let me show you the diagram first, dear students. If you look into this diagram, here if you see that PQ, let the picture come. Yeah, it came. The PQ is the focal chord. Why? Because that chord PQ is passing to the focus S of the parabola. And what is the equation of the parabola, by the way? equation of the parabola is y square equal to 4ax. This is the equation of the parabola, and we take 2 points here, dear students. One is the point P and another is the point Q. Interesting part is that if you take the point P is a parametric point, as we just learned, means if we take the coordinate of the point P as 80 square comma 280, we will see that the coordinate of the point Q should be a by t square comma minus 2a by t. Okay, so as you see in this diagram, PQ which passes through the focus is of the parabola is called the focal chord. The point P and Q, which are the point of intersection of the focal chord of the parabola, are called the extremities of the focal chord of the parabola y square equal to 4ax. And please note that if we know the parametric coordinate of any of the extremities of the parabola y square equal to 4ax, the other extremities can be found by replacing the parameter t by 1 by t. So what does it mean? So this is very interesting. So suppose P and Q are the two extremities of the parabola. So suppose you know the coordinate of the point P as 80 square comma 280. So how we can find the value, how we can find the coordinates of the point of Q, the other extremities? Just replace, t by, t should be replaced by minus 1 by t. Then we get Q as, a into 1 by t square means what? A into t square, t should be minus 1 by t. So t square means minus 1 by t whole square means a by t square, a into 1 by t square, comma 2a by minus t, so that becomes minus 2a by t. Correct now? So that means what we get the coordinate of the point Q. Coordinate of the point Q we get is that, a by t square and minus 2a by t. Now suppose, obviously it is the converse is also true, dear students. Suppose you know that coordinate of the point Q are aware of, and it is a by t square minus 2a by t. Then you replace t by minus 1 by t, then you will get the, from what I'm saying is that here if you replace t by minus 1 by t, you are going to get the coordinate of the P. So PQ are the extremities. So this is the way we can find the coordinate of the two extremities of this of this focal chord, dear students. So let me write it down, that whatever we just discussed, and I'm going to take it from the study material and just write it down so that you can follow it when you follow these video lectures later. So in this diagram, the chord PQ which passes through the focus S of the parabola is called the focal chord. That is the first point. And second point is that the points P and Q, which are the point of intersection of the focal chord of the parabola, are called the, just a minute, the point, let me first bring this statement in front of you, and after that I'll just say once more. So dear students, if you see this one, the points P and Q, which are the points of intersection of the focal chord of the parabola, are called the extremities of the focal chord of the parabola y square equal to 4ax. And the next statement what I'm going to make, dear students, is something like this, is that please note that, let me first place this statement here, dear students. Please note that if we know the parametric coordinates of any of the extremities of the parabola y square equal to 4x, the other extremities can be found by replacing the parameter t by minus 1 by t. As I explained few minutes back, if PQ be the extremities of the focal chord of the parabola y square equal to 4ax, with parametric coordinate of the point P as 80 square comma 280, we can simply find the parametric coordinate of the point Q by replacing t by minus 1 by t in the parametric coordinate of the point P. Hence, the parametric coordinate of the point Q become a by t square minus 2a by t. Correct, dear students? Our next point of discussion is called the focal distance. And we are going to discuss about the focal distance in detail, dear students. And I'm going to take you to the next page to discuss about the focal distance. So let me first bring the statement in front of you, dear students. If you look into the diagram, dear students, the focal distance of any point P on the parabola y square equal to 4x is the distance between the point P and the focus of the parabola. That is the distance SP. Suppose if we consider the point P on this parabola y square equal to 4x, that is the equation of the parabola, and S is the focus, then this SP is known as the focal distance. Now, if you see that SP is the focal distance, then once you draw that focal chord through the point P, it should actually intersect the parabola in the other extremities, that is called the P dash. Then SP dash is also a focal distance of the point P dash. So there are two focal distances, right? If you see, one is SP and another one is at SP dash, and they are related by the following equation. I just going to show it to you. Okay, so and here it is. If you see, dear students, here the statement is that in this diagram, we see that there are two focal distances, SP and SP dash. Please note the following, established result. Why I say established result is that, this can be proved, but if you are interested to get a proof of this one, we can take it offline later, or you can also do using, fundamentals of coordinate geometry, and you will get it. So it says that 1 by SP plus 1 by SP dash is equal to 1 by A. Okay, and that actually tells that 2 by 1 by SP plus 1 by SP dash is equal to 2A. So apparently it looks like the second conclusion what we did, it is a little complex than the previous one, right? But why so? Because this information, that is 2 by 1 by SP plus 1 by SP dash is equal to 2A, gives us an important conclusion, and that is that, what we see is that for any parabola, the harmonic mean of the segments of a focal chord is equal to the length of the semi-latus rectum of the parabola. Okay, what is the latus rectum of a parabola? That is 4a. For a parabola whose equation is y square equal to 4ax, what is the length of the latus rectum? 4a. So the length of the semi-latus rectum will be what? 4a by 2, that is 2a, and that is equal to the harmonic mean of the segments of a focal chord. Okay, so harmonic mean, if you recall, dear students, our sequence and series discussion, there is something called harmonic mean. If SP and SP dash, these are the two numbers, then their harmonic mean is 2 by 1 by SP plus 1 by SP dash, and that is equal to 2a. That is what is actually we conclude from this information. So this is all about the focal distance, dear students. Now, what we are going to discuss is that the position of a point with respect to a parabola. Okay, so let me show you that by means of a diagram as well, that what is meant by the position of a point with respect to a parabola. Suppose a parabola is given to you. Okay, that means what? What is the equation of a parabola? So the equation of a parabola is given to you as is y square is equal to 4ax, and a point is given to you. What is the point is given to you means its coordinates is given to you, alpha comma beta. Now dear students, if a graphical representation of the parabola and exact position of the point is given, then you can easily say whether the point is outside the parabola or on the parabola or inside the parabola, correct or not? But if such information is not given, means if such visual representation of the parabola and the point coordinate location of the point is not given, then how you can conclude? There is a better way to conclude, is that just you need to find that the value of the expression beta square minus 4a alpha. That means from the y square equal to 4ax, that means what? Y square equal to 4ax means what? Y square minus 4ax is equal to 0. So we can say that y square minus 4ax equal to 0, not dear students. Y square minus 4ax equal to 0. So what we are going to compute is that instead of y, we are applying that y coordinate of the point, that is beta square, minus 4a into, instead of x, we will apply the x coordinate of the point, that is beta square minus 4a alpha. Now, we are going to compute the value. Means actually we are interested about whether it is greater than 0 or equal to 0 or less than 0. If the value of the expression is greater than 0, then what we can say? We can say it is outside of the parabola. Outside the parabola. We can say it is outside. Let me write properly. Sometime in the digital board I face problem in writing. Outside the parabola. If it is equal to 0, if we get the value of this expression beta square minus 4a alpha is equal to 0, then what we can conclude? On the parabola. And if we get the value of beta square minus 4a alpha is less than 0, then what we can say? That the point is inside the parabola. Inside the parabola. So what does it mean, dear students? Now, if we if we have a visual representation of this thing, so if this is the parabola, then a point when you can say it is outside, this is the point where it is outside, this is on the parabola, and this is the point which is the inside. So what we can say, this is outside, that is on, and this is inside. So as I said in the beginning of this discussion, you do not have the visual representation of this parabola and the exact location of the point. All you have given the equation of the parabola, that is y square equal to 4x, and the coordinates of the point, that is alpha comma beta. With these two information, we need to conclude that whether the point is outside the parabola, on the parabola, or inside the parabola, and here it is, as I just explained to you, dear students. Now the next point of discussion, dear students, is related to the tangent of parabola. First we'll discuss about the tangent of parabola. So let's let me have this discussion in a next page, and let me take you to the next page first. Okay, so tangents of parabola. So let us take that y square equal to 4x. This is the equation of a parabola. Now we are going to find the equation of the tangent to the parabola at a particular point on the parabola. Okay, so as you see, dear students, the statement what I took from the study material is that, let y square equal to 4x be the equation of a parabola. Now, the equation of the tangent to the parabola at any arbitrary point x1, y1 is y into y1 is equal to 2a into x plus x1. At the parametric point, let me use the red color. So first one is any arbitrary point x1, y1. At any parametric point pt, that means where the coordinate of the point p is 80 squared, 280. That means coordinate of the point p is actually 80. Oops, sorry, what happened? Coordinate of the point p is 80 square, 280. At this point, what is the equation of the parabola? What is the equation of the tangent to the parabola at the point P? Is y minus 280 is equal to 1 by t into x minus 80 square. Now, dear students, if you recall, when we discuss about the parametric, form of parabola, at that time I said that, if we take that, parametric point pt with coordinate 80 square, 280, the equation of the tangent will have a slope, 1 by t, and that is what it is given. Coefficient of x is known as the slope of that particular straight line. So that is what it is clearly visible. Now, the general equation of a parabola, the general equation of the tangent to the parabola is y equal to mx plus a by m, where m is any real number except 0. That is the general equation of the tangent of the parabola, is when you know that what is the slope of that parabola, what is the slope of the tangent to the parabola, sorry, slip of my tongue. What if you know m as the slope of the tangent to the parabola, then the general equation of the tangent to the parabola is y equal to mx plus a by m. Now, you can vary m. As you vary m, you will get different tangents, and all those different tangents will have different slopes. But their general equation is of the form y equal to mx plus a by m. That is about as long as the equation of the tangents are concerned of a parabola. So there are mainly three type of points. One is that just arbitrary Cartesian point with two unknowns x1, y1. Second one is that a parametric point 80 square, 280. Now, and the third one is that the general equation of the tangent of the parabola. Now, in related to that tangents of the parabola, I would like to mention you few important points. The first one is that, if you recall this information, it will be very, if you remember this information, it will be very useful to solve problems, dear students. So I will strongly recommend to remember this as well. So the first one is that the condition that the line y equal to mx plus c be tangent to the parabola. Suppose y square equal to 4ax is a equation of a parabola. And what is the condition that y equal to mx plus c be a tangent to this parabola? Okay, the condition is that c has to be equal to a by m. That is the condition. So I repeat, dear students, y equal to mx plus c is the equation of a straight line, and y square equal to 4ax is the equation of a parabola. Now, what condition to be satisfied that straight line y equal to mx plus c to be a tangent to the parabola y square equal to 4ax? And the required condition is c is equal to a by m. Now, the second point is that the coordinates of the point of intersection of the tangents to the parabola y square equal to 4ax at the points p at1 square 281 and q at2 square, 282 is at1 t2, a into t1 plus t2. That is also very important. So what is meant by that is that if you have, you take 2 points. If I explain these particular points further, dear students, is that Suppose this point I want to explain you further. Suppose you have a parabola. This is the equation of the parabola y square equal to 4ax. Okay, so this is the equation of the parabola y square equal to 4ax. Now you have two points. One point is P with coordinate a t1 square, comma 2a t1, and another point you have. So that is the point Q, parametric point. So its coordinate is a t2 square, comma 2a t2. Now you can draw tangents to the parabola at these 2 points, no? P and Q. So if we draw the tangent, suppose this is one tangent and this is another tangent. So as you see, these two tangents, meets at a point. Suppose, R be the point of intersection. Now, as you know the parametric form, parametric coordinates of these 2 points P and Q, you can simply say what will be the, coordinate of the point R. Its coordinate should be a into t1 into t2, that is the x coordinate, and y coordinate should be a into t1 plus t2. Correct, dear students? So that is what I said in the second point. The coordinate of the point of intersection of tangents to the parabola y square equal to 4ax at the points P at1 square comma 2at1 and Q at2 square comma 2at2 is at1 t2 comma a into t1 plus t2. Now the third point is that the two mutually perpendicular tangents to a parabola always meet on the directrix of the parabola. Two mutually perpendicular tangents to a parabola always meet on the directrix of the parabola. These are the very important information, dear students. You can prove it also. Okay, but the moment you remember this kind of information, it is actually going to help you a lot while solving relevant problems. The next point is that from any point on the directrix of a parabola, if two tangents are drawn to the parabola, then the angle between those two tangents is actually must be 90 degree. Okay, I repeat, from any point on the directrix of a parabola, if two tangents are drawn to the parabola, then the angle between the tangents must be 90 degree, which is actually the statement inferred from the previous statement. That is, the two mutually perpendicular tangents of to a parabola always meet on the directrix of the parabola. So now, dear students, if I club these 2 points and give a visual representation in a different color, how it looks like. So let me give you a visual representation of this one. That means what? So suppose, this is the parabola whose equation is that y square equal to 4ax, and this is the directrix. Sorry, this is the directrix. Suppose. Now the statement says that if you take any point, suppose a point, you take arbitrary point P on the directrix. Now from that point P, you can draw two tangents to the parabola, right? So one tangent, so let me draw the tangents in different color, green color. Suppose one tangent will be something like this, and the other tangents will be something like this. Okay, now the statement, the last two statements says that the angle between them is actually 90 degree. Okay, dear students, so this is about the fundamental information about the tangents to a parabola. Our next point of discussion, dear students, is that normal of parabola, and that I'm going to discuss now. Okay, so the normal of the parabola, is the next topic, and I'll take you to the next page to discuss about this thing. So Let you know y square equal to 4ax, be the equation of a parabola. Okay, let y square equal to 4x be the equation of a parabola. Now the equation of the normal to the parabola is what? And I hope all of you are aware of what is normal. Normal is nothing but, so if I give you an just concept about the normal, we discussed in details in one of our previous classes. So suppose this is the equation of a parabola. This is a parabola looks like. Suppose its equation is equal to y square equal to 4ax. So now you take a point here. Now at arbitrary point P. Now at that point P, we can draw a tangent, right? So if we draw a tangent, and if I draw the tangent in the blue color, so the tangent will looks like this. That is the equation of the tangent. So let me draw it very properly. So this is a tangent. Now what is normal? The blue color is tangent. Now what is normal? Normal is something, so let me draw the normal in the green color. So normal is a line which is perpendicular to the tangent and passing through the point P. So then you can say that the green line is a normal to the parabola at the point P. So both tangent and normal intersect at a point P which is on the parabola. So what I said, dear students, is that if this is the tangent, so this is tangent and this is actually normal. Okay, so now this is the fundamentals about the tangents and normals. Now let y square equal to 4x be the equation of a parabola. Then I'm going to show you the equation of the normal in different forms. And you need to remember those things, dear students. Okay, so here it is. That let y square equal to 4x be the equation of a parabola. Now the equation of normal to the parabola at the point P, which parametric coordinates are 80 square comma 280, is y minus 280 is equal to minus t into x minus 80 square. Or if you simplify further, you will get y is equal to minus tx plus 280 plus 80 cube, where minus t is the slope of the normal to the parabola at the point P 80 square comma 280. Now dear students, if you recall, two times we have discussed during the today's session, is that at an arbitrary point P whose coordinate is 80 square comma 280, if you draw a tangent, what is the slope of the tangent? It is 1 by t. Now we know that tangents and normals are perpendicular to each other. So the product of the slopes of the tangent and normal should be equal to -1. Now if the slope of the tangent at the point P 80 square comma 280 is 1 by t, then definitely the slope of the normal should be minus t, so that 1 by t into minus t becomes -1. That is why, where minus t is the slope of the normal to the parabola at the point P 80 square comma 280. The equation of any normal to the parabola y square equal to 4ax at any arbitrary point am square minus 2am is y is equal to mx minus 2am minus am cube, where am is the slope of the normal to the parabola at the point am square minus 2am. Okay, dear students, so these are the two forms of equation of the normal to a parabola. Now, there are some important points, and I want you to remember these important points, related to the normal of a parabola. So what are those? So let me show you, and very important information, dear students, and I strongly recommend you to remember this thing. The first one, dear students, is that if the normal at the point 80 square comma 280, let the point comes, then I'll explain. The first point here, students, if the normal at the point at1 square comma 281 meets the parabola y square equal to 4ax again at the point at2 square comma 282, then we get the relationship T2 is equal to minus T1 minus 2 by T1. Second point, if the normal at the point a T1 square comma 2a T1 and a T2 square comma 2a T2 of the parabola y square equal to 4x meet only on the parabola, then we must get T1 into T2 is equal to 2. You may think, sir, this information you are saying, where it is going to be applied? When you get some, relatively complex problem on parabola, you will see all these things will be very important, to apply and to solve this problem in relatively lesser time. The coordinate of the point of intersection of normals to the parabola y square equal to 4ax at the points a T1 square comma 2a T1 and a T2 square comma 2a T2 is 2a plus a into T1 square plus T2 square plus T1 T2 minus a T1 T2 into T1 plus T2. That is the coordinates of the point of intersection of normals to the parabola y square equal to 4ax at the point a T1 square comma 2a T1 and a T2 square comma 2a T2. Similar discussion we had the coordinates of the point of intersection of the tangents to the parabola y square equal to 4ax at 2 points like this. Okay. Now the next point is that through a given point at least one and at most three distinct normals can be drawn to the parabola. Through a given point at least one and at most three distinct normals can be drawn to the parabola. Okay. If m1, m2, m3 are the slopes of the normals to the parabola y square equal to 4ax drawn from a given point, then we must have m1 plus m2 plus m3 is equal to 0. Dear students, all this information what I say are actually the point notes. Okay, for proof and all these things, you can go to our study material in details, and also we can take it offline. But this information is important so that you can apply it, appropriately when you get a relevant question. Our next point of discussion, dear students, is the pair of tangents from an external point. Okay, and that is our next point of discussion, the pair of tangents from an external points. Okay. The equation of pair of tangents drawn from an external point x1 comma y1 to the parabola y square equal to 4ax is below. And just let me first show you the point notes, and after that I'll explain further. Okay. The equation of the pair of tangents drawn from an external point P x1 comma y1 to the parabola y square equal to 4ax is as below. S1 is equal to t square. Dear students, what is S? S is the expression y square minus 4x. And what is S1? S1 is nothing but the value of the expression, just replacing y by y1 and x by x1 in S. That is, S1 is nothing but y1 square minus 4x1. And what is T? T is nothing but the value of the expression which is in coordinates with the in the equation of the tangent, but there is no relationship with the equation of the tangent to the parabola at the point x1 comma y1, because x1 comma y1 is not at all on the parabola. Just to memorize it properly with a proper manner, that's why I wrote it here, is S1 is equal to t square. Let me give you a visual representation of this statement. Suppose this is the parabola. Sorry. Suppose this is the equation of the parabola y square equal to 4ax. Okay, dear students, now let's take an external point. Okay, external point is what? With coordinate x1 comma y1. That is the point x1 comma y1. Now we can draw two tangents to the parabola from an external point. Correct? Suppose these are the tangents I'm going to draw in the blue color. So this is one tangent, and this is another tangent. Correct, now, dear students? Now, okay, it doesn't really looks like a tangent. Suppose this. Okay. Now, if you look into these two tangents, the green, lines, these are actually pair of straight line, right? So these are the two, points. This is one point and this is one point. Now, what is the joint representation of this pair of straight line represented by the two tangents drawn from an external point, x1, y1? To remember it easily, the way we write it as s1 is equal to t square. So s is y square minus 4ax, s1 is y1 square minus 4ax1, and t is that y1 minus 2a into x plus x1. So then these are the two tangents. Now, what is that? If you see that this is the general equation in second degree in x and y, if you apply all these values s, s1 and t square, and this is the, the pair of tangents, which is actually also a pair of straight lines, you can say. Our next point of discussion is that chord of contact, dear students. So the next point of discussion is that chord of contact, and that I am going to discuss in the next page. So let me read out the statement first, dear students. Let the pair of tangents drawn from an external point P x1, y1 to the parabola y square equal to 4x touches the parabola at two distinct points A and B. Okay. Now, as I read this statement, let me draw the equation of the parabola. Let me draw the parabola first, not equation of the parabola. Suppose this is the parabola, dear students. Okay. Now, from an external point, so this is the equation of the parabola, y square equal to 4ax. Now, let's take a point P, at this point P, which is external to the parabola, and the coordinate of the point P, as you know, it is x1, y1. Let me write it here. That is the point P having coordinates x1, y1. Now, if we can draw two tangents to this, parabola. So one tangent is something like this, and another tangent is something like this. Correct? Now, what are the point of at two distinct points? So these are the points I'm marking. The points are, this is the point A and this is the point B. Correct, dear students? Now, let me revisit the statements once more. Let the pair of tangents drawn from an external point P, x1, y1 to the parabola y square equal to 4ax touches the parabola at two distinct points A and B. Now, the straight line AB called the chord of contact. And what is the equation? So now let me draw that, AB. That AB is called the chord of contact. So if I draw that AB, just a minute, let me draw it properly. So what I draw in that line in the green color, that is known as the chord of contact. Okay, and how to find its equation? Its equation is nothing but t equal to 0. T is a symbolic representation, dear students, as if like a tangent, but not. It is not actually a tangent because x1, y1 is not on top of the parabola. So that is why it is doesn't make sense that it is the equation of a tangent. It is an equation of the chord of contact. So this is chord of contact. This is chord of contact. And how to find the equation of the chord of contact, dear students? That is actually t equal to 0, where t is the expression y1 minus 2a into x plus x1. Dear students, our next point of discussion is that chord of contact in terms of the middle point. Okay, so that I'm going to discuss now with you. That is chord of contact in terms of the middle point. So let me first, bring the point in front of you, then we'll discuss. Now, the statement, dear students, is that, let the pair of tangents drawn from an external point P to the parabola y square equal to 4ax touches the parabola at the two distinct points A and B respectively. And we know, what we know, dear students, we know the coordinate of the middle point of that AB, line segment AB. What I'm saying is that we know the coordinate of the midpoint of AB. That means if we know the midpoint of AB, means if I draw, this thing once more, it is something like this. So suppose this is the parabola, and in this parabola, this is the chord of contact. So if I draw the chord of contact like this is the chord of contact, and it intersects the the parabola at the two distinct points A and B. What we know, dear students, we know the coordinate of the midpoint of AB. And suppose this point is P and its coordinate is x1 comma y1. Then, dear students, we can find what is the equation of this chord of contact. So this is chord of contact. So chord of contact. So what will be its equation? That is equal to T is equal to S1, where T is the expression represented by y1 minus 2a into x plus x1, and S1 is the expression represented by y1 square minus 4x1. So this is the equation of the chord of contact in terms of the middle point. Now the next and the last point for today's session, dear students, is that there are some properties of parabola that I just want to tell you, because few of them we already discussed in our previous two sessions, but just want to inform you about this, some important properties of parabola. And let me first bring the points, and then I will explain. So the first one is that the first point what you see, dear students, is that the portion of a tangent of a parabola cuts off between the directrix and the point of contact subtend right angle at the focus. Okay, you can take a visual representation and understand. I repeat, the portion of a tangent of a parabola cut off between the directrix, okay, and the point of contact subtends a right angle at the focus. Second point is that the tangents at the extremities of any focal chord intersect at right angles on the directrix. Now the third point is that any tangent to a parabola and the perpendicular on this tangent from the focus meet on a line which is tangent at the vertex. I repeat, okay, the second point we already discussed. Third point is that we already discussed in one of our previous discussion. And third point is that any tangent to a parabola and the perpendicular to this tangent from the focus meet on a line which is tangent at the vertex. Dear students, with this note, I would like to conclude the class for today. Unless you have any specific question for me. In the next class, we will discuss more on in parabola, and we will discuss, we will solve more problems relevant to parabola. So thank you very much.